So here I have the BMC KVM. As you can see, is it big enough?
Yes.
I don't know if I can like zoom it, maybe just a little. Anyways,
Certainly, it seems to be initializing.
yeah. So the first thing you see is some early VGA image that is actually embedded into the firmware. What is even
What?
surprising, and someone may say that's a
Okay.
great feature, is that um, this image or this string you see on the screen is actually displayed um, on the BMC VGA very early, even before the CPU starts. So when the PSP is like initializing the memory, it is able to train the PCI Express link that is connecting the CPU and the BMC, and then send some kind of image to the VGA device present on BMC. So that way we can obtain some early VGA that says, okay, please wait a little bit because we are initializing, right? So this screen should soon go away once coreboot takes over and initializes the frame buffer on the BMC device, and then it will later display its own image. Uh, oh yeah. So you can see this. You have seen like a regular coreboot logo here because I'm using the upstream coreboot right now, and this is the default UEFI payload setup menu that is available on Mr. Chromebox CDK2 fork that is used by default in coreboot. Nothing fancy here, right? So I've got some like advanced menu, right? Maybe we can make it a little bit larger. Maybe like this. Yeah, and so it's like some very basic configurations, like the secure boot, some TPM, right? And it says that it is TPM 2.0. We have some platform setup, which is unfortunately empty. And a very basic boot manager that you can alternate boot options or boot from file, and then you have a standard boot menu which lists your bootable devices. So as you can see, I already have some PCI Express working because I'm using the KVM, right? There is a NVMe drive visible. Some USB is even working, right? However, I have still issues with SATA interface, or should I say bus. It is not initializing properly yet. But yeah, I can try to boot the Ubuntu, but as I mentioned in the very beginning, I don't expect too much luck from it. First of all, I have still some issues with CPU bring up, and I'm using the no SMP max CPUs equals 0 parameters to work around that. But even though I'm using this to skip the SMP bring up, I'm still hitting some memory corruption, and it wreaks havoc on the system, corrupts page tables and stack and everything. It just is a matter uh, of luck to actually get past through that point. But well, let's attempt. Maybe we will have some luck. If not, then well. Um, yeah, I guess it already hung, so I
Do you
got some
have any
panic.
debug access to it?
Yeah, I forgot to open Minicom, so I'll have to reset the board again and try once more. But I can show you a paste of it.
Yeah, FreeDOS. What are you saying? Boot FreeDOS. But
A
yeah,
boot FreeDOS, yeah. Good luck with that on a 64-bit system.
There's a 64-bit version of FreeDOS in development.
In development, right? So my system is also in development. How do you think this mixture will work? I doubt. I really doubt.
So let's
Uh,
try it if we're so unsure.
all right.
Maximum
So
ambiguity.
Yeah. Let me. Which paste it will be?
Maybe we can say something about the hardware, like, and I guess we could treat this discussion also a little bit as a pre discussion to your presentation, so we could have some directions.
Yeah, maybe. Just let me quickly.
Sure.
Show you what I'm dealing with. So basically, the corruption happens somewhere around these lines. I don't know whether it is some kind of bug in interrupt setup or something that leads to. Usually, these are some page faults or double faults, and yeah, everything just explodes. And yeah, I still have no idea how to deal with that. What we can say about the hardware? Well, should I open the manual maybe to just talk a little bit about
Whatever
it?
whatever you think is the most interesting. Maybe picture is interesting. Maybe
Yeah, picture is always interesting. You know, look how beautifully blue this board is. It has many DIMM slots, so you will never run out of RAM memory for sure. I don't know how many gigabytes it supports. I don't know, maybe half a terabyte or even more, possibly much more. I think couple terabytes. Anyway, okay, let me open the DTT manual quickly.
So right now you have this problem with the kernel, like probably paging issues.
Yes,
So
probably
memory map, essentially correct setup for memory map or something else.
Either that or the kernel meets some pointer that that leads to some corruption. I think I might have some, I don't know, maybe misaligned stuff in the coreboots I passed to the OS in the ACP tables or something like that. I don't know. That will be probably some lot of debugging, but yeah. Okay.
Usual work. Phil, what other hardware you have in mind?
Yeah. So let's talk a little bit now about what possible expansions we have for this board. This is also new to me because usually you have like some PCI Express slots, which you can see here and here. These are the regular X16 PCI Express slots. But then on servers, you have also stuff like the MCIO ports, which can accommodate up to 8 PCI Express lines in one connector. So as you can see, you can have 1, 2, 3, 4, 5, 6 connectors for MCIO, which can give us a total of 48 additional PCI Express lines. Of course, there's a problem with this board in general. If you would like to use like vendor firmware, then, for example, if you go to the setup page for the PCI Express, then you can see that you cannot configure those MCIO ports other than X4 bifurcation. So basically, you are forced to use only 4 links per 2 times 4 links per an MCIO connector. So if you'd like to probably connect some GPU to it on the vendor BIOS image, then you're not gonna have a 16 links wide connection here. So yeah, maybe I hope I can work around that in coreboot, where I have the freedom to actually initialize the width I want, for example, right? Also, there are like I would say those connectors are split into splitting a link on a physical link on the CPU into two parts, because each link on the CPU internal and hardware is 16 lanes wide, right? But those links can be are divided here for MCO ports to accommodate 8 lines per connector. And these links are, for example, marked here as G3A and B. So they come from the link G3, but are split into two parts for one MCO connector each. And the same goes, of course, for the for example, for the G2 or GO or G1. I don't remember whether these are like full 16 links or not, but for sure the PCIe links like these are representing those regular PCI Express slots, and these can be configured for X16. However, when I tried to do that, my card was not actually detected. So it is also explained like here that the PCI Express slots can be configured in various bifurcation modes like X16 and other combinations of 8 and 4 lines. But for example, if we choose the MCIO ports, right, we can only see that the default setting is X4, X4, and there are no alternatives. The same goes for the G3 link, which apparently also supports SATA, and the default is SATA, but of course you can bifurcate one MCIO connector to X4, X4 bifurcation. Yeah, and that's my one of second most important concern right now about the plans we have about this board. So now to maybe quickly
But is
relate
it
to the
like
presentation we want to give.
is it
Yep.
like a hardware issue, or this is hardware design, or this is just
That would be stupid, but I'm kind of worried that the board design may actually have such broken routing of those PCI Express lanes, so that even those PCI Express X16 slots do not have those PCI Express lines in correct order, because once I was mapping the PCI Express ports to the slots, I noticed that the device appeared at various offsets in the physical link inside the processor. So
soon we
so
will end up in business of hardware inspection, like deep dive hardware inspection.
yeah, exactly.
I don't see Zil Blazar with us, because he should speak
He
up.
is he is
He is,
here.
but he's not on chat. Like, he's not writing anything. So,
Maybe
that's
he fell asleep waiting for my presentation.
I don't know. Damn, the PC I think was much more chaotic than
Yeah,
yeah. So
there
my
is
point.
also a chance that
No,
the,
we're doing without schematics.
yes, we're doing without schematics, so we only can rely on information we obtain from operating system and empirically probing the hardware ourselves. And second thing is that there is a possibility that the X16 slots are actually maybe not in the exact order, but the order may be um, maybe preserved for the groups of 8 lines. So if, for example, if I swap the MCIO cables, it might actually uh, start being in the ascending or descending order of the
Yeah,
physical lines.
but based on that, we could essentially like really ask hardcore questions to the Gigabyte sales, because like they at least answering our phones to some extent. Uh, of course, like I don't think that we can get a lot, but if we will give this precise question about design of PCI lanes, and why
Yeah,
is this different or weird, then may essentially say no, it's correct and your software is wrong, or whatever. Yeah.
or rather, our assumptions are incorrect, because if we, for example, take into consideration the use case for the server, that is more like a server for storage, then bifurcation of 4 lanes everywhere makes complete sense. And from the use case perspective, it's completely fine, because you are supposed to actually connect a bunch of NVMe drives which only use 4 PCI Express lanes. So it doesn't matter whether you can or cannot bifurcate to ×8 or ×16 link.
Okay,
right?
okay, I understand. So you're essentially saying that this design is for storage, and like using it for other reasons is not a good idea.